AI hallucinations may sound like a glitch or a minor technical hiccup, but in reality, they pose one of the most significant challenges to trust, reliability, and the future of artificial intelligence. So what exactly are hallucinations in AI? In the context of language models, a hallucination refers to an output that is factually incorrect, nonsensical, or entirely made up, but presented by the model as if it were true. The term may sound surreal, but it captures a very real phenomenon. When AI generates text that looks right, sounds confident, and feels convincing, yet is fundamentally false. Why does this happen? To understand hallucinations, we need to understand how models like GPT work. These models are trained to predict the next word in a sentence based on the words that came before. They don't know truth from fiction. They don't cross-check facts with a database or understand the world like a human does. They operate on probability, not reality. This means that if a certain word sequence statistically follows a given prompt, the model might produce it, even if it's completely fabricated. For example, if you ask an AI to summarize a scientific paper it hasn't seen, it might invent citations, authors, or results that sound plausible. Ask it about a court case, and it might generate a convincing but non-existent legal precedent. These are not mistakes in the traditional sense. The model is doing exactly what it was trained to do: generate coherent, contextually appropriate language. The hallucination occurs because the model lacks grounding, a connection to verified truth. But why does this matter? Because as the AI tools become integrated into education, journalism, healthcare, law, and customer service, the cost of misinformation becomes far more serious. Imagine a student relying on an AI tutor that invents historical facts, or a lawyer submitting a legal brief based on hallucinated cases, or a doctor using an AI assistant that generates a plausible but incorrect drug interaction. These aren't hypothetical scenarios. They've already happened. In 2023, a lawyer using ChatGPT in the US cited fake court cases in a federal filing. The AI had generated legal references that didn't exist. In another case, AI generated health advice recommended dangerously inaccurate treatments. Each incident raised alarm bells about the dangers of treating AI output as truth. AI hallucinations matter because they erode trust. Users, especially non-experts, may assume that a confident, well-worded answer is accurate. But when that trust is broken, it can create skepticism not just toward one tool, but toward AI as a whole. And that skepticism can slow innovation, harm adoption, and deepen societal divide. The issue also impacts developers and researchers. Building reliable AI systems becomes much harder when models can make things up under the hood. Hallucinations are difficult to predict, test, or fix because they emerge probabilistically, not through coding errors. Even the most advanced models, like GPT-4, still hallucinate under certain conditions. So what can be done? One solution is retrieval-augmented generation, RAG. In this architecture, the model doesn't rely solely on internal parameters. Instead, it queries an external database, like Wikipedia, academic sources, or company documents, before generating a response. This allows the model to ground its answers in verifiable content. For example, Microsoft's Bing Chat uses RAG by allowing GPT-4 to search the web and cite its sources. This not only reduces hallucination, but improves transparency. Users can see where the information came from and evaluate it themselves. Another approach is fine-tuning. Developers can retrain models on curated, factual datasets, teaching them to prefer accurate outputs and avoid common errors. This improves performance in specific domains, like medicine, law, or finance, where precision is critical. There's also the use of tool use and plugins. ChatGPT, for instance, can access external tools like calculators, code interpreters, and web browsers. Instead of guessing, it delegates tasks to specialized systems, reducing the chance of hallucination when performing calculation or looking up facts. But perhaps the most important solution is your user awareness. Just as we teach media literacy, how to evaluate sources, detect bias, and verify claims, we now need AI literacy. Users should know that AI is not a source of truth. It's a language generator with strengths and limits. Understanding that distinction is crucial to using it responsibly. The hallucination problem also brings up a deeper philosophical issue. What does it mean for a machine to know something? Current models are trained on language, not grounded experience. They have no sensory input, no physical context, and no memory of interactions. They don't understand facts. They simulate understanding by pattern matching. In contrast, human knowledge is experiential, embodied, and contextual. We remember who told us what, why it matters, and how it fits into our worldview. AI does not. That's why some researchers believe the next leap in AI will involve grounded cognition, connecting language models to real-world senses, environments, or structured knowledge bases. Others are exploring neurosymbolic AI, which combines deep learning with symbolic logic to verify and reason through claims. Until then, we live with the tension, powerful language generation that sometimes sounds too smart for its own good. The hallucination issue also poses legal and ethical challenges. If an AI generates false content that leads to harm, who is liable? The user, the company, the developer. As AI systems are increasingly deployed in critical environments, the line between tool and agent becomes blurry. And with that blur comes new questions about accountability, safety, and trust. Regulators are starting to take notice. In Europe, the AI Act requires that high-risk systems meet strict reliability standards. In the US, agencies like the FTC are investigating misleading AI claims. Tech companies are being pushed to disclose model limitations and build in transparency from the ground up. At the same time, researchers are calling for hallucination benchmarks, standardized tests to measure and compare how often different models hallucinate, in what contexts, and with what consequences. Ultimately, hallucinations highlight the central tension in AI, its ability to generate language that's syntactically perfect, but semantically unanchored. And that's why it matters. Because the more we rely on AI to inform, assist, or automate decisions, the more dangerous these ungrounded outputs become. We must stop thinking of hallucinations as quirky side effects and start treating them as foundational design problems. Problems that must be tackled with transparency, user education, and constant iteration. Because only then can we build systems that are not just intelligent, but trustworthy. This also forces us to rethink what success in AI should look like. For years, benchmarks like Blue, Rouge, and Perplexity dominated how we measured language models. But these metrics often reward fluency over factuality. A model might score well on these tests and still hallucinate in practice. That's why the industry is shifting toward truthfulness benchmarks. OpenAI introduced the Truthful QA dataset to evaluate how models respond to questions designed to trigger falsehoods. Other organizations are building adversarial tests to catch hallucinations across domains, from law and medicine to everyday knowledge. We're also seeing increased emphasis on human feedback loops. Reinforcement, learning from human feedback, RLHF. The technique used to train ChatGPT involves humans ranking and correcting AI outputs to encourage truthful, helpful behavior. While this improves performance, it isn't perfect. Human raters may have biases, and instructions may not capture nuance. Still, the RLHF process is evolving. Some teams now use multi-step reasoning, citation checking, and even debate-style models where multiple AIs argue over answers to surface truth. At the product level, more tools now offer confidence scores, highlighting when the AI is uncertain. Some display real-time web sources, others include warning messages or disclaimers, reminding users to verify information. These small UX choices can make a big difference in shaping responsible usage. In education, hallucinations offer teachable moments. Teachers now use AI-generated misinformation to train students in fact-checking, critical thinking, and source evaluation. Rather than banning AI tools, some educators encourage students to analyze their flaws, turning hallucinations into lessons. Meanwhile, open-source communities are contributing to the cause. Projects like Hugging Face's Hallucination Tracker and Stanford's Helm aim to compare models across dimensions like factuality, coherence, and safety. These initiatives empower users to make informed choices and hold AI developers accountable. But perhaps the most profound implication of AI hallucinations is how they force us to reflect on our own cognition. Humans also hallucinate, just differently. Our memories are fallible. We believe rumors, we misinterpret data. We're influenced by emotion, framing, and context. In many ways, AI reflects back to us a distorted mirror of our own reasoning. So maybe the long-term lesson isn't just about fixing AI. It's about understanding how we evaluate truth in a world overflowing with information, human or machine-generated. Because in the end, hallucinations matter not just because they expose the limits of AI, but because they challenge us to be more discerning, more thoughtful, and more intentional about how we use the knowledge we receive, whether from a machine or from each other.